Hi everyone, so this is our fifth video in our revision video series. Um, as I mentioned in the previous videos, we're just going to try and work through these problems, break down some of the wording, look at how I can draw a diagram, and hopefully give you some hints and tips and annotations that you might write to your own summary journals, so that you've got some good notes to take into a test or your exam. So, a group of friends set out on a hike to a waterfall in a national park. They are given the following directions to walk from the park's entrance to the waterfall to avoid having to cross a river. Walk 5 kilometres on a bearing of 325 degrees true and then 3 kilometres due north. Round each answer to one decimal place. Now, at this point here, people often stop reading and then they do the questions A, B, C, D in order like that. It's a really good idea when you're reading the question, particularly in exams, to read the whole thing so you've got an idea of where you're going. So we need to draw and label a diagram to represent this hike, determine how far east or west the waterfall is from the entrance, find the direct distance from the park's entrance to the waterfall. And then the question goes on, the friends set up tents on level ground at the base of the waterfall at points A, 35 metres from the base of the waterfall, and B, 28 metres from the base of the waterfall. The angle of elevation from A to the top of the waterfall is 32 degrees. Determine the height of the waterfall and the angle of elevation from B to the top of the waterfall. So the second question there starts to bring in angles of elevation and depression. And so I'm also starting to think that it might be a 3D type question because we've got tents on the ground and we've got a waterfall at height. So already, without picking out the key information, I've got bearings, I've got angles of elevation, I've got due north, and I need to draw a diagram and find some lengths. So let's read through this and highlight the key information. So a group of friends set on a hike. They're given the following directions. Walk 5 kilometres on a bearing of 325 degrees true, then 3 kilometres due north. We're going to round each question to one decimal place. Don't need to highlight that whole bit. Let's actually just go back a step there and highlight just the one decimal place. All right, what is the key questioning word here? We need to draw and label a diagram. So let's highlight all parts, draw and label a diagram. Okay, let's jump in to part A now. So when we're drawing these pictures, always start with a simple point. So here's my point, here's my start. And it tells me to go 5 kilometres on a bearing of 325 degrees. So I'm going on a bearing. So as soon as I see that idea of a bearing, I'm going to put my north line because bearings are always from north. And we have to go 5 kilometres at a bearing of 325 degrees. So I know that that's 90, I know that that's 180, that's 270. So 325 degrees is going to be somewhere up here like this. And that was 5 kilometres. And the bearing, 325 degrees. Cool. Next part of the problem, they then go due north for 3 kilometres. Right, so I've got to go north 3 kilometres from here. I've actually drawn my diagram too high. I'm going to bring it down a little bit. I've got the luxury of cut and paste. You folks might need to do something more creative, maybe even rub out and start again. And 3 kilometres is less than 5, so let's go roughly to scale. That would be my 3 kilometres straight north from my starting point. Okay, so there's a diagram to represent the hike. And I'm going to put a point here that says, I'm going to call S was the start point. I'm going to call that T for where they turn. And I'm going to call that W because that should be their waterfall. Part A complete. Part B. Determine how far east or west the waterfall is from the entrance. So how far east or west? Let's think about that for a moment. First thing I need to know is, well, which way is east and west? So a quick diagram. I've got north, east, south, and west. Now, here's the entrance, and we've gone this direction, west. So it's not going to be the east part. It is going to be the west part. And we want to know how far. So how far is a length. So determine how far west from the entrance. So here, you've got to understand these questions because you get a few of them. It's a one-dimensional question. It only wants to know how far to the west it's gone. So they're actually asking you to find out how far this way, that arrow shows west, how far this way the hikers have gone to get to the waterfall. So we want to have that distance over there. We want to find out what that is. Okay, so now that we've got our picture, we've got our bearings, we want to find out that west part. Let's actually analyse our diagram. What can we use? Now I could start to look at this big non-right angle triangle here. But how far west it goes has absolutely nothing to do with this 3 kilometre part. That doesn't actually change anything at all. So what I'm going to do instead is I'm just going to use the right angle triangle that's here. Why? Because that'll be my easiest method to work out this distance down the bottom. So repeat that. I'm going to use this right angle triangle because that's the simplest way to find the distance down the bottom. So let's redraw a simple diagram. Put it over here. So we've got a diagram that looks like this. We know that that length is 5 kilometres. I want to find out this distance west. I've called it W for west. And I know I've got a right angle triangle, but then I sort of stop and I'm like, oh, this is great, but what's the angle? And so I've got to analyse my picture and say, well, what's this angle in here? I've got to find out what that is before I can do anything else. Well, if I've gone 325 degrees, I know that west is 270 degrees. So what I do in my head is I actually want to find the difference between 325 and 270. Let's find the difference. Between 325 and 270. And again, I've said about getting that inner voice going in your head because as soon as you see difference, you should know to just subtract those two angles. So 325 subtract 270 gives you 55 degrees. Hopefully I did my subtraction in my head properly. So by doing that analysis, stopping and thinking, well, what extra information can I put on my diagram? All of a sudden, I've created a simple right angle triangle. And because it's a right angle triangle, a rat, I can think that I'm going to use SOHCAHTOA. SOHCAHTOA. So label the sides. This is the hypotenuse. This is the adjacent. It is cos theta equals adjacent over hypotenuse. Substitute what you know. The angle is 55 degrees. The adjacent is W. The hypotenuse is 5. We need to undo a divide by 5. And the opposite of divide by 5 is to times by 5. So it becomes 5 times cos 55. And it's just a matter of typing that into your calculator. Which is 2.87. 2.87 kilometres. And I'm going to do a quick check. Up here, I wanted 1 decimal place. All right, let's rewrite that. Let's put just one decimal place, 2.9 kilometres. Okay, part B is done. We've got the distance west that has been travelled. Part C, find the direct distance from the park entrance to the waterfall. Find direct distance from the entrance to the waterfall. So here's the entrance, that's where I started. Here's the waterfall. There is the direct distance between those 2 points. So I go, all right, cool. I can work on that. No worries. How am I going to do that? How can I find these angles? What could I possibly do? What could I possibly use? The first thing I spot here is to use that direct distance. I've got a triangle there that I could use. I also have a triangle here that I could use. Now, the second triangle is a right angle triangle. So some of you might choose to use right angle triangles because that's going to be easier. All right, this one is a non-right angle triangle that I have two sides for. So some of you might be going, I'm going to use the non-right angle triangle. So non-right angle triangle. And you might be thinking sine rule, cosine rule. And some of you might be thinking use the right angle triangle. I'm going to use SOHCAHTOA. Now you can actually use both methods. One of them I have to play around to get the angle in here. If I've got the angle in here, I can use the non-right angle triangle. If I don't have that angle, I need to have this side length here. And if I've got that length, then I can use the right angle triangle. I'm going to use a non-right angle triangle just because I've already used a right angle triangle in this example, and so it will be just good to have another non-right angle triangle problem. Okay, so I go back to my diagram and I start analysing. Well, how can I get that angle in here? Wrong button. How can I get that angle in here so that I can use a non-right angle triangle? Well, I already know that this is 55 degrees. And when we analyse it, we know, well, the angles in a triangle have to equal 180 degrees. So 55 and 90 is 145. So that would have to be 35 degrees up the top there. And I know that a straight angle makes 180 degrees. So that angle here would have to be 180 take away 35, which equals 145 degrees. Okay, now if you also know your interior angles rules, the exterior angle of a triangle equals the sum of the two interior angles, you could have used that as well. But it is 145 degrees up there. Okay, so what does Mr. Boot always say? He says, redraw a simplified diagram. So here's the waterfall. Here's the point where they turned. Here is the entrance, which we called S for the start point. And that's the length that I want to find. I know that that angle is 145 degrees. I know that this is 5 kilometres. And I know that this is 3 kilometres. So this problem, I'm either going to use the sine rule or the cosine rule. And I hope what you would notice is I'm working with 1, 2, 3 sides, and I have an angle. So I haven't created the butterfly here. I'm not using the sine rule. I'm going to just use the cosine rule. Okay, so cosine rule. How do I use the cosine rule? Well, let's write down the cosine rule. C squared equals a squared plus b squared minus 2ab cos c. We want to find out c, or we want to find out this distance here, and this is where c is by itself, so let's call that c, capital C, a, B. Doesn't matter which way you put A and B, the fact that I've made that one C is important. So C squared equals 3 squared plus 5 squared plus 2 times 3 times 5 times cos 145. Type that into your calculator, which I'm doing off on the side here. And you get 58.57. And I'm going to remember that they asked me for one decimal place. So 58.57. 57, which would be 58.6. And I think, hang on, I've got 3 kilometres and 5 kilometres. Does that seem like a logical answer? Would 58.6 kilometres make sense? Doesn't make sense for my diagram. And that's where, again, notation, I've got the squared. Let's get rid of the squared by taking the square root. And I end up with the square root of 58 is 7.65. And then I go, that makes sense. That's a better answer. Fits in with everything else that I've done, which would be 7.7 kilometres. We've got the direct distance. Excellent. Part C, complete. Right, second part of the question. The friends set up a tent on level ground, so it's a flat surface. At the base of the waterfall at points A, 35 metres from the base, and B, 28 metres from the base of the waterfall. The angle of elevation from A to the top of the waterfall is 32. Determine the height of the waterfall. So here, what are we doing? Determine height of the waterfall and the angle of elevation from B to the top of the waterfall. Okay, so let's start our diagram again. We've got A is 35 metres, B is 28 metres from the base, and the angle of A is 32 degrees. Start somewhere. So here's A. Here's the waterfall, W, A, and that is 35 metres. And there's the top of the waterfall. Angles of elevation are always from the horizontal, so that would be there. And the angle of elevation was 32 degrees. Find the height of the waterfall. And it's this point here where I could go ahead and put all of the information about B, but when I stop and analyse what I've done and think about where I'm at, I'm like, oh, I've actually got enough information to answer the first part of the question. I've got to find the height of the waterfall. All right, so let's just go ahead here, find the height of the waterfall. This is the opposite. Sorry, I should have said it's a right angle triangle. So we know we can use SOHCAHTOA. And that's the opposite, that's the adjacent. So my rule is going to be tan theta equals the opposite over the adjacent. We substitute what we know. The opposite is h, the adjacent is 35. And then we want to undo a divide by 35. How do we undo divide by 35? We times by 35. That gives me 35 times tan 32. Type it into your calculator. And you get 21.87. And we know they asked for one, well, I don't know where I got an 8 from there. 21.87, one decimal place, so it's 21.9 metres. That's a pretty decent waterfall. It's 21.9 metres tall. Okay, let's go to the second part of the question. Find the angle of elevation from B to the top of the waterfall. Well, we know that B was closer, which is here, So I'm going to actually now find the angle up to this point in my diagram, and we know that the distance of B from the base is 28 metres. So we can put that on my previous diagram, or I can just redraw my own simplified diagram that only has the information that I need. Here's B, here's the waterfall, that's 28 metres. I want to find this angle of elevation, and that's the top of the waterfall. And I actually don't need any of this stuff over here because I know what the height is now. It's 21.9 metres. So we've created a right angle triangle that we can actually work through to solve this problem. How did I know that? I'm drawing the pictures, I'm thinking about it as I'm drawing. I'm drawing multiple pictures. Okay, I can't stress that enough. In my mind, to do these problems, it's drawing lots of different diagrams to help bring it together. So opposite, adjacent, it is a tan problem again. I don't know what the angle is this time, but the opposite is 21.9. The adjacent is 28. And if I want to find out the angle, I have to undo tan, which is to use inverse tan. Go to your calculator and type that in. So shift tan 21.9 over 28, and you get 38.0 degrees.